And this is a question from homework section 1.4, question number 5. Find the, use the Euler's approximation method for finding the solution for this differential equation when the value of x when t is 1. We have given the value of x when t is 0. And using the Euler's method, we need to find out the value of x when t is 1. But for that, our answer is supposed to be within 0.01 range. So first of all, to do this problem, we have to understand the Euler's method. So if you just click your textbook, you're going to find the detailed explanation about the Euler's method. I strongly recommend you to read this or watch the video. And this is the formula you have to use for finding the points and the value of x. Remember, this is in terms of x and y, but our problem is in terms of x and t. Okay, so I am going to write down this problem here. This is the problem, the initial value problem, and Euler's method for this problem is tn plus 1 is tn plus h, and xn plus 1 is xn plus h times the value of the function at x and tn. Okay, keep in mind the value of the function at x comma t is this expression. In this case, it's 1 plus x squared. And h is the subdivision width of a small increment. Okay, so remember the starting point is given and we would like to approximate at 1. So we are dividing the interval from 0 to 1 using this width of the subinterval h. Okay, if you read the question, this question says, hey, start with the value of h equals 0.01. So you have to understand, we are trying to divide this interval from 0 to 1 using this subinterval width of the width 0.01. That means there will be 100 different subintervals inside, in between 0 to 1. So when you try to calculate these points or the value of x, you need to calculate this 100 times. If you want to start with the value of h equals 0.01, in this problem they are asking us to start with 0.01. Our goal is to find out the value of h, the largest one, which gives us the value of x at 1 within that 0.01 approximation range. I'm going to explain you what does that mean. So to calculate this value, I'm using Excel. Without using any calculator, it's complicated. It's very time consuming. So let's start with the tn plus 1 and then xn plus 1. That's the formula we have given. Keep in mind the first value is given, t0 is 0 and x0 is 0. How do you calculate the second one? The second one is according to this formula. If you look at the formula here, it's the previous value of t plus h. Okay, the previous value of t plus h. So what is the previous value of t? You have to go here in the Excel, use the equal sign, highlight the previous value plus h. In this case we have 0.01, right? That's what we have given. Let's go there. 0.01, yeah, 0.01. So now you have to scroll it down until you get the last point, which is 1. It's just 0.25. So you have to keep going down, and there are 100 different sub intervals, so you have to go up to 100. So because we started at second cell, so you are going to get that value at 102 points. So these are the value of t. What is the value of x n plus 1? The first x0 is 0. How do you calculate the x1? Is the previous value plus h. In our case, h is 0.01 times 1 plus x square, means x means the previous value, x square. Remember, if you look at the formula, it's xn, which is the previous value of x plus h times the value of the function at x comma t. But what is the value of the function? It's 1 plus x squared. So if you replace this x by xn, which means you're talking about the previous value of x. That's what I did here. I just used that formula. Now, if I just highlight this, it's where is that? Just, yeah, I want to Yeah, so if I double click that, it's going to calculate the same thing for rest of the the values. So as you can see here, the last value, the value of x at 1 is 1.5369. But is this the value we're looking for? For that, you need to check what is the value difference, this value minus the previous value. What's the difference? Difference is 0.03, but we are looking for not more than 0.01. You see here, in this problem, if you see here, we want within 0.01 range. But if you check this value, it's more than that range. So this value of h is not working. Okay, so now we have given a bunch of different value of h. You need to choose which h is going to work, and among them, if there are more than one, you have to choose the largest one. So I'm going to choose h equals 0.0025 because I know the answer. But if you don't know the answer, start with this one. And keep in mind, you have to do exactly the same thing I did here. To find out how many subinterval there will be, what you do is just use equal sign 1 divide by the value of h. So in my case, I'm using the value of h is 0.0025. If I do that, it tells me there are 400 different points. So I go here, I update this value of h using 0.025, 0.025. Okay, this is 0.025, 0.0025, sorry, 0.0025. And I'm going to update this value as well, 0.0025. And now you just have to remember these values are not updated, so you have to just double click. What is that? You have to, yes, now it's updated. You have to do the same thing here. Yes, now when you highlight this, and when you see this sign, just double click and it's going to update everything. If you go down here, it just goes up to 102, but our goal is to go up to 400 points. Why? Because for this age there will be 400 different points, so you have to just scroll down up to 402. Remember, we are starting at third cell, so you're going to get 1 when it's 402. So now for the x value, if I go to the last one and highlight that, and I get this and double click, now it's going to fill out everything. So the last value for this second column, this is the value of x at 1, but is this in that approximation region? So for that, what you do is just find the difference between this one and the previous value. If this difference is less than 0.01, you're good to go. So as you can see here, this difference is less than 0.01. So that's why, this is the right h for us. So I'm going to choose h equals 0.0025. Keep in mind, I already know the answer. That's the reason I just jump into h equals 0.025. You can do the same thing using different h until you get that answer. Okay. Now, next question, what they are asking you is, hey, this time we're not looking for the value of x. We're looking for the value of t such that the value of x at that t would be 1. Keep in mind, that value of t is supposed to be within this 0.02 range. Whenever you have given this range, just make it half and choose that h. So half of this is h equals 0.01. If you choose h equals 0.01, h equals 0.01, the way we did before the first time, 0.01, because the double of 0.01 is 0.02. So within that margin, we need the answer. Okay. And now h equals 0.01, we just have to go up to 100 points. So just highlight it, go up to 102, go up to the first point where the value of the second column is 1. This is the first value where the value of the second column is 1. You see that? And this is the second one. Find out the difference between these two values. We're looking for the t value, not the x value. We found the first value where x is 1, and we found the second value of t where the x is 1 point something. Are they the difference between these two, is it less than 0.02? Yes, we already know because that's how we chose our h, by making the half of that difference. So if you find the difference between 0.8 and 0.79, it would be 0.01, which is less than 0.02. So you can pick 0.8 as your value of t0. So zero point 0.8 would be, and plus minus this value would be within that range. Okay, so that's how you can do this. Problem cannot be done without using calculator like Excel. Okay, I hope you understand that.